welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be looking at acid, base, and salt. And today we are looking at solubility. So we are going to define what solubility is and also tackle a few questions on solubility. So when solutes are added to a solvent, they dissolve to form a solution. So a solute plus a solvent is equals to a solution. And if a solution has a lot of solute dissolved in it, it's said to be concentrated. And if it has little solute dissolved in it, it's said to be dilute. So we know there is a limit to how much a solute can be dissolved in a given amount of solute at a solvent at a given temperature. And usually say the maximum mass of that solute that can dissolve in 100 grams of solvent at a specific temperature is what we refer to as solubility. So when no more solute can dissolve at a given amount of solvent at a specific temperature, then we say that solution has reached a saturated solution. And then some other salts, usually when you heat them, they're able to dissolve more solute. So in the saturated solution. So let's say a solution has reached a saturation point. If you increase the temperature, some of them you can add more solute. Like now we see that that solution has reached a super saturation. So this is the formula of calculating solubility, although we are going to look at some few examples to actually see how that works out. So you start with potassium nitrate. So let's look at the solubility of potassium nitrate. So 50 centimeters cubed of distilled water is placed in a beaker, as you can see in the image shown. And then potassium nitrate is added at a time while stirring continuously. The nitrate is added until no more will dissolve and there is an excess undissolved salt present, as you can see. This is the saturated solution of potassium nitrate at that temperature. The solution is allowed to settle and its temperature is recorded. So about 25 centimeters cubed of a clear solution is poured in a previously weighed evaporating dish, and then the mass of the dish and solution is recorded. And the dish is then heated in a water bath to avoid spurting till the solution is concentrated. The concentrated solution is also allowed to cool and then weighed. So some of the things that we notice from this reaction is that the temperature uh, is 20 degrees Celsius. So the mass of the evaporating dish plus solution is 100.7. The mass of the evaporating dish is 65.3. The mass of the solution is 35.4, and the mass of the evaporating dish and dry salt is 73.8 grams. So from this result, we can do a few calculations. First of all, we can determine the mass of the salt that dissolved. That means that you're going to take the mass of the evaporating dish and salt and the mass of the evaporating dish. That way we are being left with only salt. We're able to know how much salt that we dissolved in the beginning, which is 8.5. And then after that, we can get the mass of the solvent because we need the solute and the solvent. So the mass of the solvent, we are going to take the mass of the solution minus the mass of the salt now. So it means the rest is water. So the mass of the water is 26.9. So we say that if 8.5 grams can dissolve in 26.9 grams of water, what about 100? So that brings us to this equation, which gives us 31.6. So the solubility of potassium nitrate at 20 degrees Celsius will be 31.6 grams per 100 grams of water. So that's how those weighing has been done, and you're able to determine the solubility even from the laboratory experiment. So let's do a few examples so that you can be able to understand the steps of calculating. So you have been told to calculate the solubility of potassium nitrate if 5 grams of the salt is dissolved in 50 centimeters cubed of water. So we have to convert this centimeters cubed of water, this volume, into density, into mass. And we know the density of water is 1 grams per centimeters cubed. So it is 1 gram in 1 centimeters cubed. So what about 50 centimeters cubed, which gives us 50 grams. So we'll be working with a mass of 50 grams. So if 5 grams dissolves in 50 grams of water, what about 100 grams? Because solubility has to be in 100 grams. So after that, you crisscross, which gives us 5 times 100 divided by 50, which will give us 10 grams per 100 grams of water. So that is the solubility of the nitrate. Next question is calculate the solubility of potassium chlorate if 50 grams of the salt was dissolved in 250 centimeters cubed of water. Once again, we convert the volume of the water into mass. We know that the density of the water is 1 gram per centimeters cubed. So that means it's 1 gram in 1 centimeters cubed. So what about 250 centimeters cubed, which gives us 250 grams. So if 50 grams of the potassium chloride dissolves in 250 grams of water, what about in 100 grams, because that's what we want. You cross multiply, which will give you 50 times 100 divided by 250, which gives you 20. So this is 20 grams per 100 grams of water. So another question. So if the solubility of potassium chlorate is 5 grams in 100 grams of water at 80 degrees Celsius, how much can dissolve in 5 centimeters cubed of water? Now this is like going in the opposite direction. So we have the solubility, which is 5 grams per 100 grams of water. So we have been told 5 grams of the potassium chlorate dissolves in 100 grams of water. What about, in this case now we've been given the volume, which is 5 centimeters cubed. We convert that into mass. So we said the density of water is 1 gram per centimeters cubed. That means 1 grams in 1 centimeter cubed. So what about in 5 centimeter cubed, which gives us 5 grams of water? So if 5 grams of the salt dissolves in 100 grams of the water, what about 5 grams of the water will dissolve how much salt? So 5 grams times 5 grams over 100 grams, which gives us 0.25 grams of potassium chloride. Let's do another question. If the solubility of potassium chloride is 72 grams in 100 grams of water at 20 degrees Celsius, how much can saturated grams, 25 grams of water? So once more, we have been given the solubility, which is 72 grams in 100 grams of water. So we are being asked how much salt can saturate 25 grams of water, or how much salt will we need to fully dissolve in 25 grams of water. So once again, we convert in this case, you can see the water has been converted into mass. So we are not going to do the conversion. So we will say if 72 grams of the salt dissolves in 100 grams of water, What about in 25 grams of water? So we will cross multiply, which will give us 18 grams, and this is the 18 grams of potassium chloride. And then let's do one last question. This one is going to be a little bit different than what we have discussed, but the same. The solubility of potassium chloride at 40 degrees is 34. So let's write that down. Is 34 grams per 100 grams of water. Determine the mass of salt and mass of solvent. So this is what we are looking for. Present in 100 grams of saturated solution at 40 degrees Celsius. So we have 100 grams of the saturated solution. So we know that 100 grams of water dissolves 34 grams of salt. So the first thing we calculate is the mass of the solution, because that is what we have been asked. Then we are going to do the subtraction. So the mass of solution from solubility is 34 grams of the salt is dissolving 100 grams of water. So the total solution is 134 grams. That is the mass of the total solution. So we say that 134 grams of solution dissolves is in 100 grams of water. So what about 100 grams of the solution? Because that's what you have been given. You have been told present in 100 grams of the saturated solution. That way we get to know the amount of water that we will need. So if 134 grams of solution dissolves in 100 grams of water, what about 100 grams now of solution? Total of everything would dissolve how much in water? So it's 100 times 100 divided by 134. This will give us 74.6 grams. And whatever we found is the grams of water. So this is the amount of water that will dissolve. So we know that a salt plus solvent will give us solution. So we know the solution is that 134 grams. And now we've gotten the solvent, which is 74.6 grams. So how can we get the salt? We can get the salt by subtracting. So 134 grams minus 74.6 grams, which will give us, I've made a slide here. The solution is not 134. 134 is for the solubility. This is 100, which will give us 25.4. So 25.4 grams is a solute that the salt or solute will need, and then the solvent will be 74.6. Remember, we have answered these two questions. So that brings us to the end. You can go and check other questions on solubility in the website. You get to practice a bit more. So next, we are going to look at solubility curves. So see you in that session.